If a gaseous mixture containing 8.5 grams ammonia and 11 grams carbon dioxide has a total pressure of 1 atmosphere, then what is the partial pressure of the ammonia? And the answer is D, 0.67 atmospheres. Now, this problem deals with a mixture of gases, and it's asking about a partial pressure of one of the component gases. So you should be thinking along the lines of Dalton's law of partial pressures. I'll remind you what that is. Dalton's law states that the total pressure of a mixture of gases equals the sum of the partial pressures of the component gases. So the total pressure equals the pressure due to the ammonia, or the NH3, plus the pressure due to the CO2. Now, these terms are the partial pressures of the component gases. And that's actually what we're asked for here. We're asked for the partial pressure of the ammonia, and we're given the total pressure, but we're not given the partial pressure of the CO2. An alternate way to calculate the partial pressure of one of the gases is as follows. The partial pressure of the ammonia equals its mole fraction times the total pressure. So the mole fraction of the ammonia is simply the number of moles of ammonia divided by the total moles of all of the gases. So the number of moles of ammonia over the number of moles of ammonia plus the number of moles of CO2. That's the mole fraction of ammonia, and we do know the total pressure in this case. Now, since we're given the masses of the two gases, we can figure out how many moles there are, and therefore the mole fraction of the ammonia. And multiplying that by the total pressure, we can get the partial pressure due to the ammonia. The number of moles of ammonia in 8.5 grams NH3, to calculate moles, we need the molar mass. That's 1 nitrogen plus 3 hydrogens, or 17 grams per mole. And for CO2, you have 1 carbon and 2 oxygens, that's 44. So the number of moles of ammonia would be 8.5 grams over 17, or 1/2 of a mole of ammonia. And for CO2, that's 11 over 44, or 1/4 mole of CO2. You can see that the total number of moles is 3/4 of a mole. Now, plugging in these numbers, the number of moles of ammonia would be 1/2 of a mole, and the total number of moles is 3/4 of a mole. That fraction right there equals 2/3. And so what we're left with is 2/3 times the total pressure, and that's 2/3 atmosphere, or 0.67 atmosphere. And so that's the answer, D.